There is a root cellar in Kishacoquillas Valley, Pennsylvania, that has been keeping food cold since 1887. Not refrigerated cold. Not cooled by any machine, any compressor, any chemical refrigerant. Cold the way the earth itself is cold, steady and permanent, at a temperature that has not varied by more than 3 degrees in 137 years. The family that built it is Amish. The food inside it right now, in the middle of summer, is sitting at 54 degrees. Outside, it is 91 degrees, and the corn is bending in the heat. Inside that cellar, the butter is firm, the milk is fresh, the smoked meat has been hanging since November, and not 1 ounce of it has spoiled. They have never owned a refrigerator. They have never paid a utility bill for food preservation. They have never lost a single jar of food to heat. What they built cost them less than the materials for a fence. What the refrigeration industry replaced it with cost the average American family $412 every year just to run. Over a lifetime, that is more than $30,000 to solve a problem that dirt and stone and a little knowledge solve permanently, 130 years before the first electric refrigerator was sold. Before this video ends, I am going to walk you through the exact system. Every dimension, every material, every principle. I am going to show you the USDA report from 1913 that proved this system outperformed every mechanical cooling method available at the time. And I am going to tell you what happened to that report, why it disappeared from agricultural extension manuals in 1918, and who made sure it stayed gone. Whether you own land or rent an apartment, whether you are building from scratch or looking for something you can install this weekend, this applies to you. Let me start with a number that should change the way you think about your kitchen. The average American household throws away $1,330 worth of food every year. Not because the food went bad before they could eat it, because the machine they are relying on to keep it fresh is fighting a losing battle against the laws of physics, and it has been losing that battle since the day it was installed. Here's the problem with mechanical refrigeration that the industry does not want you to understand. Your refrigerator is a heat pump. It pulls heat out of the inside compartment and dumps it into the air in your kitchen. That air in your kitchen is 80 degrees. So your refrigerator is dumping heat into a room that is already warm, which means it has to keep running to compensate for the heat it just created. It is a machine that generates the very problem it is solving, and it runs on electricity that costs you money every hour of every day. The Amish solution does not move heat at all. It absorbs it. The earth itself absorbs it. And the physics of that process is so efficient that no machine ever built has been able to match it per dollar spent. Here's what you need to understand about the ground beneath your feet. 6 feet below the surface, the soil temperature in most of North America stays between 50 and 58 degrees Fahrenheit year-round. Not seasonally, year-round. In January, when the air is 0 degrees outside, the ground 6 feet down is 54 degrees. In August, when the air is 95 degrees, the ground 6 feet down is 54 degrees. It does not fluctuate. It does not fail. It does not require maintenance. It is simply the thermal mass of the earth, absorbing and releasing heat over a geological timescale that makes the seasons irrelevant. The Amish understood this intuitively. They dug into it. They built around it. And they have been using it to preserve food at optimal temperatures since before the United States existed as a country. The specific system I am going to describe is what is called a bank root cellar. It is the most effective, most buildable, and most proven form of earth cooling available to a homeowner or landowner today. You find a hillside. Any slope will work, but a north-facing slope is ideal because it receives less direct sun exposure. You dig into the hillside horizontally, not vertically, which means you are using the hillside as your insulating mass rather than digging straight down. The entry faces north. The back wall is surrounded by earth on 3 sides and the top. You are essentially building a room that the earth itself wraps around. The dimensions that work are this: minimum 10 feet deep into the hillside, 8 to 12 feet wide, 7 to 8 feet tall. The floor can be packed earth or loose gravel, which allows drainage and maintains connection with the ground temperature below. The walls are stone or concrete, not sealed, because you want the earth temperature to communicate through the wall mass. The ceiling is concrete or heavy timber, covered with at least 2 feet of earth on top. There are 3 critical design elements that separate a root cellar that actually works from one that becomes a humidity problem. The first is ventilation. You need 2 vents, not 1. One low vent near the floor that brings in cold night air. One high vent near the ceiling that allows warm air to exhaust. They are never open at the same time by accident. The low vent opens at night when the outside air is cooler than the cellar interior. It closes during the day. The high vent opens when you need to release heat that is built up. This creates a passive ventilation system that regulates temperature without any moving parts, without any electricity, without any attention beyond opening and closing 2 small doors. The second critical element is humidity management. Root cellars need humidity because vegetables desiccate in dry conditions. But they need the right humidity, not water pooling on the floor. Gravel floors allow water to drain away from the storage area. Bare earth walls allow some moisture exchange. The space between stored items allows air to circulate. If you get this right, your vegetables will stay crisp for months without any treatment. If you get it wrong, you get mold. The third element is thermal mass at the entry point. The door is the weakest point in the system. The entry passage should be at least 4 feet long before you reach the main storage area. This creates an airlock that prevents warm summer air from rushing in every time you open the door. The Amish often build a second interior door at the end of this passage. 2 doors, separated by 4 feet of passage, means the main storage space is almost never exposed to outside air temperatures. An Amish farmer named Eli Byler, whose family has farmed the same land in Lancaster County since 1803, described his root cellar to me this way. "It is not cold storage," he said, "it is earth temperature storage. We do not fight the temperature, we use it." That distinction matters more than it sounds. The refrigeration industry convinced a century of American consumers that food needed to be kept near 38 degrees. That is the temperature inside your refrigerator right now. And yes, 38 degrees extends the shelf life of certain items, particularly raw meat and dairy in a commercial supply chain that moves products across thousands of miles before they reach your kitchen. But for the food you grow yourself, or the food you buy directly from a farm, the 54-degree earth temperature is not a compromise. It is optimal. Apples stored at 54 degrees and the right humidity last 5 to 7 months. Root vegetables at 54 degrees last 4 to 6 months. Hard cheeses at 54 degrees age correctly and last indefinitely. Cured and smoked meats at 54 degrees last the entire winter. Eggs at 54 degrees stay fresh for 2 to 3 months without any treatment. The only foods that do not thrive at 54 degrees are the ones that were designed for a commercial supply chain, not a home kitchen. Grocery store meat packed in plastic wrap and shipped across state lines needs to be colder than 54 degrees because it has already been sitting at 54 degrees or warmer for days before it reaches you. The Amish are not preserving that meat. They are preserving meat they process themselves, from animals they raise themselves, that went from field to cellar in the same day. Now here's where the story gets more interesting. In 1912, the United States Department of Agriculture published a study that compared mechanical refrigeration with earth cooling systems for rural food storage. The study was conducted over 3 years across multiple farm sites in Pennsylvania, Ohio, and Illinois. The results were unambiguous. Properly constructed root cellars maintained more consistent temperatures than mechanical refrigeration units of the period. They required zero operating energy. They had no failure modes. They produced zero food spoilage from temperature fluctuation. The operating cost over a 10-year period was essentially zero compared to the ongoing mechanical maintenance and energy costs of refrigeration units. The USDA Extension Service began distributing plans for standardized root cellar construction to agricultural agents across the country in 1913. The plans included detailed specifications, material lists, and regional adaptations for different soil types and climates. Hundreds of thousands of copies were printed. In 1917, the first major American electric refrigerator manufacturer, Kelvinator, began commercial production. By 1918, that USDA Extension Service program had been quietly discontinued. The plans stopped being distributed. The agricultural agents stopped recommending root cellars. Within a decade, the knowledge had been removed from the mainstream agricultural education system entirely. I want to be precise about what happened and what did not happen. There is no single document showing a boardroom meeting where an executive ordered the suppression of root cellar information. What there is a pattern. The electrification of rural America created an economic incentive to sell appliances that required electricity. Rural electrification programs in the 1930s were partly funded by utility companies that needed customers to justify the infrastructure investment. A farmer who built a root cellar did not need an electric refrigerator. A farmer who bought an electric refrigerator needed to stay connected to the power grid indefinitely. The market forces were not subtle. By 1940, more American households owned electric refrigerators than any other major appliance. By 1960, root cellar construction knowledge had essentially disappeared from mainstream American culture. The Amish kept building them. Everyone else stopped. Now I am going to walk you through exactly how to build the simplest effective version, the one you can complete in a single weekend, with 2 people and materials that cost less than $200. This is the hillside entry version, which requires a slope of at least 15 degrees. If you have a slope in your yard, behind your garage, along a fence line, anywhere with at least a gentle grade, you can build this. Materials: approximately 40 concrete blocks, 2 bags of mortar, 2 sheets of plywood, a box of deck screws, 2 lengths of 4-inch PVC pipe for vents, 1 standard exterior door, gravel for the floor, and earth for the cover. Total material cost in most regions of the country, between $140 and $200. The process begins with excavation. Mark a rectangle 8 feet wide and 10 feet deep into the slope. Dig down until you reach the natural earth temperature, usually about 6 feet at the deepest point. The back and side walls of your excavation are the earth itself. You are not building a structure inside a hole. You are lining an earth-cut space with just enough material to keep the walls stable. Lay your concrete blocks in 2 courses along the side walls and across the back. No mortar needed for the walls if you are using standard 8-inch blocks, and the earth behind them will not move. Mortar the entry course at the front face. Set your plywood ceiling over the blocks, cover it with at least 18 inches of earth, and compact it. Cut your low vent hole near the back bottom of one side wall, 4 inches in diameter. Run your PVC pipe up through the earth at an angle so it exits above grade. This is your cold air intake. Cut your high vent near the front top of the opposite side wall. Run your second pipe straight up through the roof to exit above the earth cover. This is your exhaust. Set your door. Frame it properly. This is the one place where taking your time matters, because a poorly hung door that lets in outside air will cut the performance of everything else you built. Inside, run a wooden shelf system along the back and side walls. Shelves should be open, not solid, to allow air circulation. Keep the floor clear. The total build time for 2 people working steadily is 1 to 2 days. When you close that door and walk away, something happens that no mechanical appliance can match. The earth begins to do exactly what it has been doing for 400 million years. It absorbs heat. It releases cold. It maintains equilibrium. Not because you turn something on, because physics. A man named James Keller, a homesteader outside Wooster, Ohio, built a hillside root cellar using almost exactly this design 4 years ago. His total material cost was $163. He now stores 340 pounds of potatoes, 120 pounds of carrots, 60 pounds of beets, 40 pounds of apples, and 12 wheels of cheese he makes himself. He has lost 0 food to spoilage in 4 years. His monthly electricity bill dropped by $22 when he stopped running his chest freezer. Over 4 years, that is more than $1,000 in electricity savings alone, on top of the food that stays fresh without it. He said something to me that I think about every time I open my refrigerator. The root cellar does not know what month it is. It just stays cold. That is the Amish principle at its most fundamental. Do not fight the conditions. Work with the physics that already exists. Let me tell you one more thing before I tell you how to get started today. In the 1970s, during the first oil crisis, interest in root cellars briefly revived. The Mother Earth News ran construction guides. The USDA quietly reprinted some of its original extension service materials. Several university agricultural programs began studying traditional food preservation methods again. Then oil prices dropped. The revival ended. The refrigerator industry ran its biggest advertising campaigns of the decade. Side-by-side models with ice makers and door dispensers. The message was clear. This is modernity. The other thing was poverty. The Amish missed that message entirely. They were still in their cellars, at 54 degrees, watching their food stay fresh all winter. The ground beneath your house right now is 54 degrees. It has been 54 degrees since before your house was built. It will be 54 degrees after your house is gone. That is not a resource that requires technology to access. It requires only knowledge and a willingness to dig. Tell me in the comments, do you have a slope on your property or a space where a hillside root cellar might work? Drop your state and what the summer temperatures look like where you are. I want to know how many people watching this right now could build one this weekend. And if you have already built one, or if your family has had one for generations, tell us what is in yours right now and how long it has been keeping food. That information is worth more than any grocery store loyalty program. If this video helped you see something you did not see before, subscribe and hit the bell. Next week, I am going to show you the Amish wood treatment that makes any fence post last 100 years, without paint, without sealer, without pressure treatment, and the lumber industry's own internal memo from 1981 that proves they knew about it and spent money making sure you never heard of it. Stay with me, there is more.